Hello everyone. I'm Nabin Malakar. I'm working with Dr. David Larry, and I'm going to present something about the work that we did, ocean ecosystem classification using machine learning. We have talked about the importance of the classification in the global scale. I'm going to be focused on the work that we did for the Gulf of Mexico region. We applied the machine learning techniques to classify the Gulf of Mexico ecosystem. So Gulf of Mexico is very important because it provides the food, income, recreation, and source of employment for the region. Approximately 95% of the commercial fish are dependent upon the estuarine and nearshore habitats of the region. So it is very critical that decision makers and managers are able to frequently access the habitat situation and the degradation over the time. But the vastness of the Gulf of Mexico is so huge and it is so dynamic that it's nearly impossible to take the in situ data and analyze it. So we are going to be using the machine learning techniques. We have talked about the importance of the coastal and marine ecological classification standard called CMEX. The collaborators at NOAA and NatureServe have been working on to develop this standard as global as well as regional, national standard, so that we'll be talking in the same language, or it will be the standard for all the scientific purposes. It will be helpful because it will make us a single language to communicate between the decision makers and the scientists. The variables that we are going to be considering for our machine learning techniques are these, which have been discussed by me, and it has been found to be playing very important role for the commercial fish habitats. I'll not go into the details, but those are the variables. We have used an unsupervised, multivariate and non-linear machine learning techniques called self-organizing map. It is unsupervised because we can apply this to unseen data, a new kind of data. Let me give you an example of the meaning, what we mean by the unsupervised techniques. Suppose you go into a garden and you know that there are 5 trees, and you look into the ground and then collect the leaves. Because you know that there are 5 kind of trees, you know which trees do it belong to. But if you go into a garden where you collect the leaves, but you have no idea how many plants are there, then in that case you have to apply techniques such as unsupervised techniques. So you have no idea how many trees are there, how many kinds of trees are there, but you have to learn from the data and then classify. Okay? So what it essentially does is it produces a low-dimensional discrete representation of the input data. So we let the data speak for itself, and it produces a map, which is very helpful for classification purposes. So we use it. Similar to other machine learning techniques, it works in 2 phases: training and mapping. If you are interested in the theoretical details, which is very huge, please look into the Cohen's paper. This is a cartoon showing the 5 variable layers that we have. We have collected, and our collaborators at NOAA, Navy, and NatureServe have collected 5 years worth of data for every month, taking the monthly average, and we input this data into the machine learning system and train the neural network. Once the neural network has been trained for the whole data range, then we come back and then apply it so that we can map it for every month of data. So this is just a cartoon showing what's happening is the machine learning system picks out the characteristic signal from the pixels from all the relevant variable and then summarizes it. The result is that the dimension reduction of this data into a single layer. So the result of our self-organizing map is basically going to be something like this. This is the central Gulf of Mexico, and we have considered 64 64 classes here. So we call it SOM classes. By looking at this picture, what I would like to emphasize is the following. The colors which are similar to each other, for example this red and over here, have this similar kind of signature with each other, which differs significantly from the other colors which are here. So the importance of this is being reflected in the fact that once you can characterize commercial pieces such as let's say brown shrimp, if you can characterize which time of the year or what is the temperature or physical all physical parameter that it thrives on that particular time or in that particular region, then you know you have characterized where these pieces are likely to be found. So we have now created an automated system which can take this data and then create the automated web page for all the data. This is just an illustration for Central Gulf of Mexico where we have created the web page for 2005 to 2009, all the months. And it is a more general framework, so we can apply it to any other regions, which we are hoping to apply to the global scale, as we mentioned. So if you click into those pages, it takes you to the details. One of the important features that we would like to highlight is the grid plot. Grid plot is a star-like multivariate representation of the data. For example, if we have high dimension of this data, it's really handy to represent it using the mean values of the data, and we see that the classes which are closer to each other are very much similar to each other than the classes which are farther apart. Since we could see the mean values of the variables, and we could see how the signature is varying across the classes, we thought it would be also important to create another plot which could show us the distribution of the data variables. For example, here sea surface temperature is more or less symmetric, whereas the sea surface salinity is not symmetric here. So it shows our wave plot, which is giving us the 5, 25, 50, 75, and 95% of the data distribution, which is pretty handy if you want to make the correspondence between our self-organizing map classification and the CMEX classification standard. For example, the sea surface temperature was classified as warm because it was in the range which was decided by our collaborator to be warm. So we have this, which can tell us, not only tell us the distribution of the data, but also it can tell us which class it is inside in that framework. And in addition to that distribution plot, we have also established one-to-one correspondence between the self-organizing map classification and their CMEX classification. Here a table is demonstrating the percentage values of the water column for particular SOM class, self-organizing map class, and the color codes are similar to the one that are represented in the picture. Another feature of this web page would be to be able to see which classes are there. So as I told you before, the machine learning system is able to pick out the characteristic signal from particular location. And so, for example, let's see here, class number 16 was around this area. So once you could establish the correspondence between the favorable temperature or favorable salinity for a particular kind of commercial fish, then you can tell where it could be found. So then you can tell the decision makers or the commercial fishermen to go, okay, you want to go here if you want to find this particular kind of fish because these are being favored by. It's, by the way, probabilistic now. Going to the probabilistic. And we have also observed that there are particular interesting seasonal or annual variation in the area of the classes. Like some of the classes disappear for some of the time, whereas it is dominating in some of the times, which can also be seen on the map. So to summarize, our products are the following. We have done the self-organizing map classification, and we have established the CNX correspondence between our self-organizing map classification and the global, which could be potentially global classification standard. We have obtained grid plot which could show us the signature of the water component, water column component at any place. We have developed the weight plot which shows us the distribution of the variable, and we have observed that there are interesting patterns in the interannual or interseasonal for that particular class. If you are interested, it is tinyurl.com/SOMGAM. It is under UT Dallas main space. Please go there, and we are looking forward to have any collaborative opportunities with all of those who are interested. So, I clicked it late, didn't I? So next step would be to have the correlation abundance map for the commercially interesting pieces, and we are working towards that. I hope to present it next time. And these are my references. Thank you for your time.